Okay, here are my slides for chapter 2. I feel like I have a lot of slides, so I might go a little fast. We want to give our viewers a sense of the data without overloading them with TMI. So we can provide numerical summaries or graphs, and that's what we'll be talking about today. I honestly don't know if this is even a thing anymore. Stem and leaf plot seems kind of old-fashioned, but it's covered in your book, and I can sort of see how it works. If you had a small data set and you were organizing it, you could do a stem of 1 and a leaf of 9, and that represents 19. And then all the 20-something responses would be in this row, and the 30-something. So maybe you could imagine this being people's ages. On this side, we've got it more organized so that the leaves are actually in order. This was just how they came out of the data. So this seems sort of like a thing that you would use in a more low-tech world like 50 years ago. But at a glance, we can gather that the 20s, 30s, and 40s are the most popular ages. This almost is like a sideways bar graph. So it is useful in that sense. Write out a list of the data values represented here. So can you do that? 20, 30, 32, 35, 41, 41. So the stem and leaf plot represents numbers in a very specific way. Mean, median, and mode, you've learned before. This is just going over that again. We could have a bimodal data set. And median, if you have two middle values, you average them. I alluded to this earlier, but if you have data with no decimals, then you can keep your mean to 1 decimal. If your data has 1 decimal, you can keep your mean to 2 decimals. So that's just a rule of thumb. I don't think I have this answer handy, but if we average these, then we would keep 2 decimal places. So median income is different than mean income. And notice that in this table, it's saying that the average income is $41,000, but the median income is $34,000 for that same age group. And I think we've taught, what class did I learn this about? I think we learn about this in Math 105, where we learn that the mean gets skewed to the right of the median. So if you have data that's skewed to the right, meaning we have a few older people, or in this case, we have a few people with really high incomes, then that skews the data. It skews the mean to be higher. So there's a few people with higher incomes, and they're making the average look higher. But the median would be lining up all the 25-year-olds from poorest to richest, and then finding the one that's right in the middle. So the middle income is lower than the mean income. Percentile is another way of analyzing our data. If I said that a person who makes $52,000 is in the 75th percentile, that means that they are richer than 75% of the people in this age group. Now, that same person might be in the 64th percentile if you were only looking at 45-year-olds. So that tells me that 45-year-olds make more money And so this person is only richer than 64% of people. And I found this website where you can put in who you're comparing yourself to. So that was the 18 to 100 that we had. And then we put in $52,000 or whatever you want. You can change this around and then generate the income percentile. And we'll see that that individual is richer than 70% of people. If it was a household, then that household only is richer than 38% of households. And there's even a graph down here. So you can see that there's a lot of people down here in the lower income brackets, and then there's just a very thin scattering of extremely wealthy people stretching out here. The graph on that website looked like it was going to be similar to this one. This is sort of old, and I never found a newer version of it. Distribution of household income for the US in 2014. So that's 10 years ago. And this is definitely skewed to the right. And we have the percentiles in blue here. So the 50th percentile means you are richer than 50% of Americans if your household makes $53,700. And you are richer than 90% of Americans if your household makes $157,500. So those percentiles, you may have also heard of percentiles if you've had a kid or know someone with a kid. Sometimes they say the weight or the height are in a certain percentile. Like if your kid was really tiny, they might be in the 10th percentile, meaning they're only bigger than 10% of kids. And if your kid is really tall, they might be in the 95th percentile, taller than almost all the other kids. I thought this was a cool graph showing global income distribution. There's a lot going on there, but it's showing you there's a lot of lower income people in India, and overall Chinese people are making more money. I don't know if this is individual or household income. And then the quote-unquote developed countries, which is, I guess, where the United States is placed, has higher incomes, but there's a broad spread. So there are poorer and richer people in the United States. You can't generalize too hard. And same with Latin America and the Caribbean. There's a very wide range of values for that green section. But you can definitely see that Latin America is wealthier overall than sub-Saharan Africa. And that purple region is a little confusing. It's grabbing a lot of different parts of the world. And I'm not sure why those were grouped together. Anyway, I just thought this was cool and I wanted to show it to you.